All right, we got it. We got it. Okay, here we go. All right, we are on what we call day. Let's look. Day 2. 13-3, day 2. Um, if you look, it says I can find what today? Yes, the length of an arc of a circle. So basically, this is what I want you to find today. Take a circle and find the arc right here. Okay, how long is this piece of the circle on the outside edge? And then given this angle, and today this angle right inside here is going to be measured in what? Radians. Okay, and that's your theta. They call that the central angle. Okay, so that's what I want you to find. But you guys already know how to do this because I already showed you just, I'd say 5 minutes ago. Let me just show you one more time. If I give you any circle, and I tell you the radius is, it's a terrible circle, r equals, let's say, 12, okay? Now, if I measure my circle in radians, we should know if this is 12 from here to here, then if I go 1 radian, that's 1, how far have I traveled around the circle from here to here? 12, correct? Yeah? Okay, so if I go 2 radians, which is about here, then I've traveled how far? That's 2 radians. Now it's 24. And if I go 3 radians, which is about here, right here, 3 radians, now it's 36. And the question becomes, when you reach the halfway mark, which is how many radians? 3.14. You got to understand something. You were doing this in your head, weren't you? To get that 24, weren't you taking 2 radians times the radius, 3 radians times the radius? So how do you get this distance?
Just multiply it by pi.
Multiply it by what?
Pi.
Okay, so you'd say the radius 12 times pi radians. Now, I could have said 3.14 times 12, right? Which one's the better answer, by the way?
Pi.
Pi, because pi is actually the
Exact.
Yeah, you punch that in and that thing goes out forever. And that's the best answer. Although some students will plug that in and be off a little bit, okay?
You don't.
It just depends on the problem. If the problem says tenths, probably not, because you won't be wrong. But if you have to go to the hundredths or the thousands, you're going to be off. Okay, so guys, this is how you do it. So I've already showed you this, and I showed it again. What do you think the formula is? The formula for arc length, what is it?
Arc.
Okay, here it goes. Say it again. Radians times pi. He's close. When he says radians, he's talking about your central angle times, and when he says it, he's talking radians. How many radians did I travel around the circle? 3.14. But then what did I do with that number? I multiplied it by what? The radius. So today, you'll take your angle times your what? Radius. And your radius, they just go small r. And this is what they do, right here. That's your formula for today. And by the way, arc length, they give it a letter. They call it the letter S. S for what? Arc length. Don't ask me why. They put S there. But S equals your central angle in radians times your radius. And I just did one for you. I took your radians, 3.14, times your radius. And we never did come up with an answer here. Probably go with this one. This one's the better one. What is pi times 12? I'm thinking close to 37, 38. Pi times 12?
37.7.
30 what?
7.7.
Okay. So how far have you traveled around the circle? Well, if this is 12 inches, you have traveled 37.6 inches. Okay? That is all we're doing today. Arc length. That's it. So we got about 3 problems to do. Let's go back right here. Now, in your notes, you might want to clean up that formula a little bit. The formula is right here. you might want to write it a little bigger. S equals R times theta. Okay. S, you might want to write the word arc length. Okay. R is the what? What's R? Radius. Okay. And theta, you might want to write it must be in what? Degrees or radians? Radians. You guys, that's what I was dealing with, was radians. Okay. There you go. So S is arc length, R is radius, and theta is the measure of your angle, central angle in radians. And this is all you're going to use in today's assignment, right here. Okay. Here we go. First problem. Use the circle at the right. What is the length of, what's the length of what? B to the nearest tenth. Well, B happens to be right here. How far around the circle did I travel? Okay, so that's arc length. You're looking for B. So I could say B equals, and by the way, B is arc length. Help. What's the radius of your circle? 3 inches. 3 inches. So radius times theta. So you say 3 inches times what? Say again. Yes, it's okay. So the central angle is right here. All you care about is the angle that makes up the arc. That's it. You could care less about that one. And the other one's not given. So 2/3 pi. So you've got your radius times your central angle in radians, and this will be the answer. Okay? If I did it in my head right now, guys, do you see something canceling? A 3 on top with a 3 on the bottom. What's the answer?
2 pi.
The answer is 2 pi. How far have you traveled around the circle? But it says to the nearest what? 10th. You probably already know this one. If you double pi, what do you get?
6.3.
You actually get 6 point, if you double 3.14, so 6.28. But to the nearest tenth, that would be what?
6.3.
6.3. What's the unit?
Inches.
Inches. You've gone from here to here. How far? 6.3 inches far. That's how far you went. You could tell me the answer is 2 pi inches, but see, 2 pi doesn't mean a lot to me. I'll go, you said 2 pi? What's 2 pi? Oh, 2 pi, that's just 6.3 inches. Gotcha. That makes more sense to me. Okay? Questions? That's so funny.
I said 2 pi because you just kept saying 2 pi, and that's just what I thought of. You just kept saying it.
Okay. Hey, question. Why was that easy?
Because it was very
No, no.
Give it to us.
It's simple. What? Guys, that was an easy one. Why? Because they gave it to you in radians, your central angle. Now this one, not going to happen. Find the length of an arc with a radius of what? 7. And an angle measure of, oh, you don't even have a number, do you?
No.
I'll make it up for you. Ready? 210. Okay. This one got harder on you. And if you don't know why, you'll see in just a second. I would draw a picture. I like pictures. It makes a lot of sense to me. Would you guys agree with my picture right now? That I went about 210?
Yeah.
Okay, okay. So there's your angle. Now, the arc length is here. This is the arc length. How far did you travel? There's your formula. I'm going to put an S there for you. That's S, the arc length. Who's got it? I'll just take a
Oh,
look.
no, I didn't get how to just, I was going to see it, how to find the radios.
Okay, I'm not going to tell you that, John. John, you're on your own. Because that was actually last Friday's assignment, how to change it back to radians. No, it isn't. I'm not sure where the 22 is. Where'd you get the 22? Radius times what? Radius times pi. No, 210 is not. No. Hey guys, you can't. Do you guys know you can't use 210 degrees? You can't use it. It's in degrees. I said this formula is only good for what? No, radians. You've got to get radians. So what is this angle right here? Right here? In radians. Yeah, it's 210, but you better convert this thing. You better convert it back to radians. Okay? Yeah, that's it. I couldn't read your numbers are so loose. I couldn't read them. No? Did you get it? Anything here?
For sure, round two.
Chance. Doesn't really say, so just whatever you want. Yep, that's it. Hey, is that inches or miles? What is it? Centimeters. Yep. 7 quite.
Oh, I got
Did you get it? Okay, you're a little high. Oh, because you rounded it.
It was
3.7.
really
You must have rounded. I would have rounded. I would have just calculator take care of it. Round the answer.
What'd you get?
Get them 6 pi. All right, here we go.
What?
Is that the reading?
That is the, yeah, that's 210 answer.
So you multiply by 7.
Yep. Okay. All right, here we go. From last Thursday when I taught the lesson said, if you want to go from degrees to radians, how do you get 210 to become radians? Multiply by what?
180 over pi. Or
No,
pi
pi
over
over
180.
Yep, there you go. Okay, now here's the nice part. The degrees, they do cancel out, so you get 210 over 1 times that. That's 210. Well, actually, 10 goes here 18 times, 10 goes here 21 times. You get 21 pi over 18, but then you reduce that to 7. 3 goes in here 7 times. 3 goes in here 6. So guys, what's this central angle in radians? 7, 6 pi. Don't use 210 or else you get it wrong. So now you plug it in. 7 for the radius. What's your central angle? 7, 6 pi. This is 7 over 1. Straight across. Answer. 49 pi over what? 6 inches, but I don't, guys, this doesn't even hardly make sense to me. 49 pi over 6, what's that? Punch it in. Just put it on my, here. Yes. Put it all in that black folder right there. And that's right. Okay, help me. What's 49 times pi divided by 6? 25 what? 0.7 inches. Okay. I traveled 25.7 inches around the circle from here to here.
Well, if I did this like the wrong way and I got the same answer.
What'd you do?
I just did 210 pi over 180,
210 pi
and I solved that out.
over 180.
Which rounds to 3.7.
And then did you take it times 7?
No.
Oh, you did?
I'm just telling you, so I did 210 pi over 180.
Okay.
And I did that, and that equals 3.7. And I did that times 7, and I got 25.7.
No, you didn't do
That's
it
what I
wrong.
got.
You didn't do it wrong. Here's the only thing I don't like what you did. You see this? I mean, this that's what I have. I have 210 pi over 180. I just reduced it to the lowest terms. Did I have to reduce it? No. but I did. Now, here's what, I don't like that you did this, because you're rounding before you get your answer. Adrian, I probably would have done this. 210 times pi times 7, all of it over what? 180. That's what I would have done. I just typed it in my calculator right here. Boom, 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 divided by 180. Not sure if the answer is going to be that much different. Probably not.
It was like 110.
Yeah. So, you know what I'm doing? I'm so used to reducing my fractions, I just do it. You don't have to because you're typing it in. But guys, if I ever said leave your answer in terms of pi, you have to reduce your answer. Okay? Anyways, that's it. Hey, question. Does this make sense that that's the answer?
Yes. What do you mean, in pi or?
No. I'm saying the answer is 25.7. Does that even make sense?
Yes.
Who says yes? I hear Harry. Okay. Will one of you say yes, and this is why? Tell me why you think it makes sense.
Because the diameter would be 14 inches, and it's farther than the diameter, so it must be greater than 14.
Okay. So you're really that's a very broad way to reason it. I mean, I get what you're saying. Yes.
I checked it with I defined the circumference.
Oh, okay.
Oh.
So when you found the circumference, then what'd you do?
I times it by 7, 12. 7 over
7 over 12.
12. Wherever I got that from. But
Okay. Yeah, I don't know either. Yeah, Aaron.
I think it's like
Listen.
pi is 3.14. The radius is 3.14 of half of the circle, which is like 21, and then it's slightly past 21, so it
Okay.
has to be 25.
So you're saying that this is half a circle's how far?
3.14.
So
So
y-
7.
Yeah, so guys, what he's doing is he's doing this. He knows this is how many radians half a circle is. He took it times 7 in his head and knew that was about what? 21 something. And then the answer is just a little further down, 25. So that kind of makes sense, doesn't it? The other way, the way I look at it is like this. I go like this in my head. I go, if this is 7, 1, 2, 3. I mean, to me, from here to here is how far? 7. What's this? 14. What's 3? That's 21. 4 ends up being about here. 5's here. 6 is
Are we
here.
ever going to learn those like factions?
No. But what I'm trying to show you is where they land. So if this is 21, this would be like 28. And you're telling me what here? 25? Yeah, this makes sense to me. But you know what would not have made sense to me? A 45 or a 50. That would have been like way over here again. So I like to know my answer kind of makes sense. Don't you? I don't want to just accept 25. I want to kind of go, yeah, that looks about right. Okay, here is another problem. Us reading the story, an application problem about, okay, what about this satellite? This satellite's going to go around Earth. It's going to make a circular pattern. I want to know how far the satellite travels, so I do want to know the arc of the circle. Is your hand up or are you just tapping?
Oh, I was gonna ask a question.
Okay,
So
go
we're
ahead.
gonna have one that's like 400 degrees. So we're gonna like.
Well, if I gave you 400 degrees, I would hope you'd say, I don't like that. I'm going to just subtract a circle. What is 400, really? If I said 400 to you, you could say that's the same as 40. That's what I would do. Okay? All right. So guys, look at the picture over there. If I were you, I'd redraw the picture. It says a weather satellite is in a circular orbit 3,600 feet above Earth's surface. So what I would do if I were you, I'd go like this. Here's Earth. Okay. Satellite's up here. How high? Above the Earth. How high above the Earth? 3,600 kilometers, right? Okay. And this satellite completes one orbit every 4 hours. So it's going to go around the Earth, right? Okay. In how long?
4 hours.
4 hours. Okay. So it takes 4 hours to get around the Earth. Here's the question though, how far does the satellite travel in what?
1 hour.
1 hour. So it takes 4 hours to go around the Earth, right? But it's only gonna travel for 1 hour. How far did it travel in 1 hour?
Well, 90 degrees.
Okay, 1 second here. Okay, look, where's the center of the circle? I just gotta ask you.
The core.
Is it where in the core?
The center of the core.
The
Yeah,
hottest part,
right here.
where gravity's the strongest.
That's it. Right there. So from the center of the Earth to the edge of the Earth, how far is that?
600.
Look over there, yep, yep. 6 what?
6,400.
Okay, guys, that's where I quit talking. Can I give you a minute and a half to come up with the distance it travels in 1 hour? Okay, I know that's not a lot of time. Just try it. Just see what you get. I would have drawn that picture over because that picture is kind of confusing. That's your answer. Is that 6,000? Well, 16. You are close, but you're off. Okay, well, I mean, you're off actually quite a bit, but you're close. I don't know what you did.
Okay, so
So you said.
okay, I'll try
Right. 1 out of 4. Which is.
Okay. So you want to
Yep, that's good. I still see that. What are you gonna do now?
Really?
Is that right?
I did. I did it right.
Well, see, here's my question. I think you did that. And see, that's too much behind. You should actually hit. I'm not sure how you did that. What you're saying is good, but your answer is. Yes, but go ahead. Okay. Oh, yeah, get it out of that. There's a way to get it in the decimal point. I don't know how to do that anymore.
I think your phone's going on.
There's a way though.
It's got
Is that a
Oh,
ringtone?
Yeah, what's
It's so sketchy. Alright,
I'm
let
in
me
Sorry,
check.
it's a notification. It's not visual.
That's the
It's from
exact-
UND.
Oh my god.
Yeah, I guess it is the
My bad, guys. So sorry.
it's a ringtone?
Your guess is
I want to go to.
We need a ringtone.
Call Bill.
Do the thing.
Wait, yeah, I
Hoping to see, like, how do you find yours? How do you find it?
Yeah. Yeah.
I don't know. There's a way. There's a way to get it back to you.
I have it.
You have it, right? Yep. Yep. Okay. Sorry, I didn't make my way around. But if you have an answer, go ahead, raise your hand. Yeah, what do you got here?
I got.
How many kilometers did it travel?
I said 15,708.
15,708 kilometers.
Yes.
Anybody say yeah? That's right.
That's my close.
What was it?
5 people agree with you, Aaron. And those 5 people are correct, by the way. Let's try it. Ready? First of all, did you understand the radius of your circle is 6,400 plus 3,600? What's the radius? Isn't it 10,000? Right? Since the bell's going to ring, guys, here's what happens. 1 out of 4 hours is 1/4 of a circle. 1/4 of a circle is 90 degrees. 90 degrees is pi over what? 2. So there's your theta. So pi over 2 times what? 10,000? That ends up being 15,700.
7.96.
There it is.
I rounded it.
Mr. Baker.
Thank you. Chuck, Hannah, I need you please. Okay. Anybody else?
Mr. Baker.
Yeah.
Guess what?
What?
You can also from just that without doing anything more, find how many miles per hour it's going.
How many miles?
Yeah, you could find it out, yeah.
Yeah,
We have to do some heavy.
Anyway,
You already just have it.
Yeah,
right
you
there.
have it.
It's kilometers per hour right
Oh.
there.
Oh, yeah.
And then you just have to convert that to what is it, 2.2 kilometers per mile?
I meant to say kilometers per hour, my bad. Okay, don't be on the track.
0.62 miles equals 1 kilometer.
Okay. And then you just, yeah, put that one first, then you know it's mile per hour.
Yeah, so we do what?